Every mechanic I know does this. None of them advertise it. Walk into any independent shop with a fleet account. The guys maintaining taxis, delivery vans, company trucks. And if you look closely at what they're doing differently from the standard oil change, you'll see it. A small, almost forgettable step that adds maybe 4 minutes to the job and costs about $3. And those vehicles? They're rolling past 300,000 miles like it's nothing. I've been trying to figure out why this never makes it into the owner's manual. Why is it not on the service checklist at your dealership? And the more I dug into it, the more the answers started to make a frustrating kind of sense. Here's the thing. This isn't complicated, it's not proprietary, and it costs less than a cup of coffee, which is exactly why nobody's selling it to you. Think about economics for a second. Your dealership makes money on parts, on labor, on repeat service visits. A $3 item that extends your engine life by 100,000 miles is not something they're motivated to hand you at the service counter. It's not cynical to say that. It's just how the business works. The same applies to the oil change chains. Their model is built on volume and return visits, not on sending you home with something that reduces how often you need to come back. And the manufacturers? Their warranty period is typically 5 years or 100,000 miles. What happens to your engine after that point isn't really their engineering priority. They build to spec. They meet the standards. They're not building engines designed to hit 400,000 miles, because that's not the product cycle. So the information that actually keeps high-mileage engines alive tends to live in one place, with the mechanics and fleet. Managers who get paid based on uptime, not service frequency. When your job is to keep a vehicle running every single day, you learn fast what actually matters. Before we go any further, let's kill the confusion. Because when I say filter trick, I'm not talking about upgrading to a $60 performance filter or some synthetic media marketing gimmick. I am not talking about an air filter upgrade, a fuel filter flush, or anything that requires a professional to install. What I'm talking about is your engine oil bypass filter. Specifically, the addition of a secondary bypass filtration canister, which you can mount under your hood in about 20 minutes, and which runs in parallel with your existing oil. Filter to catch the particles, your factory filter physically cannot. That's the whole thing. That's the 3 trick. Well, the filter media refill for the canister costs about $3 per oil change interval once you have the setup installed. The initial canister itself runs between $40 and $90 depending on the brand, which sounds like a lot until you understand what it's actually doing to your engine. To understand why this actually matters, you need to know what kills most engines, and it's not what you think. Most people assume their engine wears out from heat or from mileage or from neglect, and those factors do contribute. But the primary cause of engine wear in well-maintained vehicles that get regular oil changes, that run the right spec, is particle contamination in the oil itself. Specifically, particles in the range of 5 to 20 microns in size. Here's why that number matters. Your factory oil filter, the one that comes standard on every car, the one you replace every oil change, is typically designed to filter particles down to about 25 to 40 microns. That's its efficiency range. It does its job well. But anything smaller than 25 microns passes right through it and stays in circulation. Now think about what 5 to 20 microns means physically. A human hair is about 70 microns wide. So we're talking about particles roughly 1/10 the width of a hair, invisible to you, invisible to your shop technician. Invisible to anyone who isn't running an oil analysis, but not invisible to your engine bearings, not invisible to your piston rings and cylinder walls. Those components have tolerances, the gaps and clearances between moving parts, that are often measured in the range of 10 to 20 microns themselves, which means a 15 micron particle isn't small relative to those surfaces. It's exactly the right size to wedge between them, score the metal, and start generating wear debris. And here's where it compounds. Wear debris generates more wear debris. A scored bearing surface creates metal particles. Those particles circulate. They score more surfaces. You end up in a cycle that accelerates over time, and it's the reason that high-mileage engines often degrade faster the older they get. It's not just age, it's accumulation. Think of it like sand in a gearbox. A little sand, a little grinding. More grinding means more sand. The oil eventually becomes a slurry of wear products that your factory filter isn't rated to remove. This is what's called the fatigue wear mechanism, and it's been documented in tribology research, the science of friction and wear, for decades. Studies from organizations including the Society of Automotive Engineers have shown that reducing the average particle size circulating in engine oil can reduce wear rates by anywhere from 50 to 70% over a given interval. That's not a marginal improvement. That's the difference between an engine that's tired at 150,000 miles and one that's still tight at 300,000. I pulled oil analysis reports from 3 vehicles, all past 300,000 miles, 2 of them taxis, 1 a fleet service truck, and the pattern in every single one was impossible to ignore. Blackstone Laboratories, which is one of the most respected independent oil analysis companies in the country, publishes wear metal data across thousands of samples. When you look at their published averages, iron parts per million, copper, chromium, aluminum, the numbers in fleet vehicles running bypass filtration consistently sit 40 to 60% below the sample average for their engine type. Not slightly below, not within margin of error. Dramatically lower wear metal counts at odometer readings that should, by normal standards, show significant degradation. The taxi in the analysis data I reviewed was a Toyota Camry with a 2.5-liter four-cylinder. At 318,000 miles, the iron count in the oil was 12 parts per million. The published Blackstone average for that engine at a standard interval is closer to 28 to 35 parts per million. That engine was producing less wear metal at over 300,000 miles than most of the same engine type produces at under 100,000. The fleet truck, a Ford F-150 with the 5.0-liter V8, showed similar patterns. At 340,000 miles, the engine had never been internally serviced. No bearing replacements, no ring jobs, no machine work. The bypass filter canister had been draining and refilling every oil change since mile 1, and the oil analysis tells you exactly why the engine is still healthy. Now, these are individual data points. I'm not presenting them as a controlled clinical trial. What I'm presenting is a pattern that shows up consistently enough across enough analysis data that it's hard to dismiss as coincidence. Now, to be fair, the manufacturer's position on this is that their standard filtration system is engineered to spec, and they're not wrong about that. When Toyota or Ford or GM designs an engine, they engineer the filtration system to meet the requirements of the warranty period under normal use conditions. The oil filter specification, the drain interval, the viscosity recommendation, these are all tested and validated. And for the overwhelming majority of drivers who trade in their vehicles at 80,000 or 100,000 miles, the factory system is genuinely adequate. It does what it needs to do for the life they expect that vehicle to have. The counter-argument from engineers who've looked at this more deeply is that adequate for warranty and optimal for longevity are two different engineering targets. When you're designing to meet a 100,000-mile benchmark with acceptable wear characteristics, you're not necessarily designing for 350,000 miles with exceptional wear characteristics. The filtration spec reflects the first goal, not the second. And here's where the technical service bulletin trail gets interesting. Multiple manufacturers, including Ford and General Motors, have issued TSBs over the past decade related to oil consumption, sludge buildup, and wear in engines that were being serviced exactly to factory spec. The issue wasn't that owners were neglecting their vehicles, it was that the factory spec, under certain conditions, short trips, high load cycles, high ambient temperatures, wasn't capturing the particle contamination accumulating between drain intervals. The response from the manufacturers was typically to shorten the drain interval or move to a higher quality oil. Not one of those TSBs recommended bypass filtration, because that's not a product they sell. But the underlying problem they were acknowledging was exactly the fine particle contamination issue that bypass filtration directly addresses. So here's what the mechanics who run high mileage fleets are actually doing and why it costs $3. The setup is a bypass oil filtration canister. Brands like Amsoil, Wix, and a few specialty manufacturers make them, that taps up into your engine's oil system at the oil pressure sender port or a dedicated adapter. The canister runs in parallel with your main oil filter. It doesn't replace your factory filter. It runs alongside it. The bypass filter uses a much denser filtration media, typically cellulose or synthetic fiber, rated down to 1 to 3 microns, which is why it's a bypass design rather than a full flow design. Running all your oil through a 2-micron filter would create too much restriction at cold start. So only about 10% of your oil flow at any given time passes through the bypass canister. But over the course of an hour of driving, all of the oil in your system will pass through it multiple times, continuously removing the fine particles that your factory filter cannot touch. The filter media inside the canister is what costs $3. It's essentially a toilet paper roll or a comparable dense cellulose filter element, and you swap it out every oil change. Some people use actual toilet paper, a single roll of Scott 1000 specifically, which has the right fiber density. And this is documented going back to the 1940s in industrial equipment. Others use the purpose-made replacement elements from the canister manufacturer. Either way, the cost per interval is negligible. Installation varies by vehicle, but most modern engines have an accessible oil pressure port, and the canister itself mounts with a bracket to any solid surface in the engine bay. The hose connections are standard AN fittings. If you're comfortable doing your own oil changes, the installation is within reach. If you're not, any independent shop can do it in under an hour. After installation, the only ongoing step is swapping the filter media at each oil change. That's the 4 minutes. That's the $3. And according to every oil analysis data point I've reviewed on vehicles running this system, that's what's responsible for wear metal counts that look like. They belong in a new engine on vehicles with 6-digit odometers. Now, before you go order 10 of these, let me give you the honest breakdown, because this matters more for some engines than others. If you're driving a turbocharged engine, anything with a turbo, whether it's a small displacement 4-cylinder or a diesel, this is the highest priority application. Turbocharged engines run more heat through the oil system, they have tighter bearing tolerances in the turbocharger itself, and they're more sensitive to particle contamination. If your turbocharged engine has over 80,000 miles on it, you're already in the range where fine particle accumulation is affecting wear rates. Adding bypass filtration now will slow that progression significantly, even if you can't undo what's already accumulated. If you're driving a naturally aspirated engine that spends most of its life on the highway, consistent speeds, consistent temperatures, regular oil changes, the factory filtration system is doing a more effective job under those conditions. You'll still benefit from bypass filtration, but the urgency is lower. If you're on a high mileage vehicle, you intend to keep anything past 150,000 miles that you're planning to run to 250,000 or beyond. This is one of the highest return investments you can make per dollar. You're not reversing existing wear, but you're dramatically slowing the rate of future wear. If you're under 50,000 miles on a newer vehicle and you want to build in protection from the start, installing bypass filtration early means you're running clean oil for the entire life of the engine. The vehicles that consistently hit 400,000 miles tend to be the ones that had this kind of protection from relatively early on. One caveat worth mentioning, if your engine is already showing oil consumption, significant blow-by, or you're getting heavy wear metals on an oil analysis, bypass filtration alone isn't going to fix the underlying mechanical issue. It's a prevention and longevity tool, not a repair. Address the root cause first. The wildest part about all of this is that the people doing the most miles, the fleet managers, the long-haul guys, the shop owners with 400,000 on their personal trucks, they're not doing anything exotic. They're not running 15 per quart oil. They're not rebuilding their engines every 100,000 miles. They're not using miracle additives or secret compounds. They're just removing the one thing that quietly destroys engines from the inside out over time, and they're doing it for $3 an oil change. The information has been available in industrial maintenance literature for decades. The oil analysis data is there for anyone who wants to pull it. The mechanics doing this on their own vehicles aren't keeping it secret. They'll tell you if you ask. It just never makes it into the consumer conversation because there's no margin in it for anyone selling you something expensive. Check your engine bay this weekend and see whether there's an accessible oil pressure port on your engine. Most have one in 5 minutes. Of research on your specific model will confirm what size fitting you need. If you want to see the follow-up where I break down the installation process step by step on 3 different engine types, including what to watch out for, and which bypass canisters are actually worth buying, hit subscribe so you catch it when it goes up. And if you know someone running a high mileage vehicle, they're trying to keep alive, send them this. It's the kind of thing that's worth knowing before you need it, not after.